Welcome everybody, welcome back from lunch and welcome to our panel that we named Institutional Web Archiving Initiatives to Support Digital Scholarship. My name is Martin Klein. I'm in the research library at Los Alamos National Laboratory and I have the honor of moderating this all-star panel today. So let me briefly introduce our speakers. First of all, we have Emily Escamilla. Emily is a graduate student in the computer science department at Old Dominion University in Virginia in the US. And she's also a member of the Web Science Digital Libraries research group there. Some of you will be familiar with their outstanding work on analyzing web archives in that realm, right? All things Memento and web archives. Following Emily, we'll have Talya Cooper. Talya is the software curation specialist at NYU in New York, also in the US, and she's soon to be the research curation librarian at NYU as well. And last but surely not least, we have Sarah Potvin. Sarah is an associate professor in the English department at Texas A&M University, also in the US. Formerly, and that's a little bit about background of Sarah, she was the scholarly communications librarian at Texas A&M as well. So that's how this all connects. And just briefly, in terms of format of the panel, we'll have all three of our speakers give a brief introduction, their background, share some slides with you, some ideas with you, roughly for 10, 12 or so maybe minutes, to leave plenty of time then for hopefully a very vivid discussion, giving you a chance to respond to the provocative points that you'll be offered. And so if this turns into a lively discussion towards the end, we'll probably leave somewhere between 15 and 20 minutes for discussion at the end. That would be great. So that's the whole intention of a panel here today. And with that, I'll shut up and hand it over to Emily.
Is this on? Perfect. Okay, yeah, like Martin said, my name is Emily Escamilla, and I will be talking about archiving source code referenced in scholarly publications. So here we have an example of a preprint within Archive, and within this preprint it says, we have begun work with an open source software package named Odin that, I'm testing my eyesight here, that aims to implement this computational framework in an efficient and accessible manner. And here they're including a GitHub URL. GitHub, GitLab, SourceForge, and Bitbucket are all Git Hosting Platforms, or GHPs. They're great for version control and allow for collaboration on code, which makes them really popular among software developers. They also make code discoverable, and we're noticing an increasing number of these links to GHPs within scholarly publications, just like what I showed on the previous slide, where we have scholars saying, for more information, go over here. However, Google Code and Gitorious are two examples that show us that these Git hosting platforms are not permanent. If you've never heard of Google Code or Gitorious, that's because they no longer exist. Users were depositing their code expecting some kind of permanence, but these platforms no longer exist. Scholarly publications as a whole are pretty well preserved with initiatives like Locks, Clocks, and Portico. These are initiatives that do archive the scholarly publications, but they do not preserve anything that the scholarly publications are linking to, including links to the web at large or source code. So the definition of scholarly products has broadened in recent years to not just be these PDFs, but broadened to include code, data, videos, and all kinds of things like that. So while the publications are well preserved, the things that they're pointing to is not. Zenodo and Software Heritage are two initiatives that are attempting to address this problem for software preservation. They maintain the versioning that's inherent within these Git hosting platforms and allow users to download the code. However, they don't capture the ephemera or the context surrounding the code. On the right, there's a screenshot of the issues page within GitHub. If you're not familiar, this is a page that allows other users besides the owner to report problems, have a discussion about features that they wish existed, and things like that. There's also pull requests where other software developers can make changes to the code and hope to have them included in the official repository. and Wiki as well, that's for documentation. All of these things come together to add context to the code product itself and how it got to be what it is. But Zenodo and Software Heritage do not capture that. They capture just the code itself. And so in that way, they essentially function as a code repository. Web archiving, as I'm sure most of you are aware, comes from a very different perspective where we're looking to capture the entire web page. It shows the user what that specific web page looked like at a certain point in time. GHPs are not typical web pages, though. Because we're looking at software code, especially scholarly products, they have to be archived for reproducibility. We want to be able to run this code again. So if you're missing something that makes it so that the code doesn't run, that's obviously a problem. So it requires completeness. And incidental archiving does not lend itself towards meeting the reproducibility and completeness needs for GHPs. But how prevalent are these GHP URIs actually within scholarly publications? To answer this question, we looked at Archive, PubMed Central, and Texas A&M's ETD corpus. For Archive, that's a STEM preprint service that has over 1.5 million articles. For PubMed Central is a corpus of biomedical and life science journals. We had over 1 million publications from them. And then we also looked at the Texas AMU electronic theses and dissertation corpus that contained 22,000 ETDs. By looking at these three corpora, we want to look across multiple disciplines as well as publication types, ranging from preprint all the way to ETD. So looking at Archive and PMC, Sarah will talk later about the Texas AMU corpus. For Archive and PMC, you can see starting on the left in 2007, about every publication contained about one URI to the web at large, but that has steadily increased to now publications in 2021 contained an average of 5 URIs to the web at large. So we're seeing an increasing use in web resources within publications. If we look specifically at GHP URIs, we see that starting 2007 is pretty low. Less than 1% of publications have a GitHub or GHP URI. But in 2014, GitHub starts to take off, and it has steadily increased ever since, to the point that in 2021, 1 in 5 archive publications contains a link to GitHub alone. SourceForge, Bitbucket, and GitLab have all stayed relatively low, as you can see on the bottom of that graph. When we look at the PMC corpus, it tells a similar but different story. We can see that in 2008, SourceForge was by far the most popular of the 4 Git hosting platforms, and it steadily decreased until 2015, when we see GitHub overcome SourceForge to be the most popular. But we see that similar trend where GitHub kind of catches fire and just keeps going. I'd like to point out here that this is on a very different scale, which makes sense that we have about 3%, and that makes sense for our biomedical and life science corpora. Obviously, they have a very different usage for repositories as well, but we are still seeing the same trends across disciplines. Okay, if they're referencing them, are those links still available? So we looked at what percentage of these GHPs are already rotten, and rotten refers to reference rot. If you navigate to that link, can you still get there? And for GHPs, that can either mean that the repository was removed completely and it's dead, or it was made private by the owner. However, both of these situations make it so that the code is no longer publicly accessible. And we found that over 6% of these GHP URIs are already rotten, which accounts for over 8,882 GHP URIs across our corpora. And if you look at Bitbucket specifically, they have close to 25% of all links to Bitbucket are no longer accessible already. And Bitbucket is still alive and well, but these links are gone. So then we looked at, well, if they're disappearing, are they archived? So we looked specifically at software heritage and the web archives and the holdings there. And we found that 13.3% of these GHP URLs are not archived, which accounts for over 16,000 unique GHP URLs and repositories that are not archived at all. And also interesting on this graph, we found that The vast majority of these URLs were archived by either web archives alone or software heritage in addition to the web archives, but only a very small portion of these were archived only by software heritage. So the key takeaways from my portion: Git hosting platforms are not permanent, but we are seeing an increasing number of links to these GHPs, where even 1 in 5 publications contained a link to GitHub. And at least 8,882 scholarly GHP URLs are already gone, and over 16,000 have not been archived. So there is a need for better archiving approaches for GHPs to preserve the scholarly record, including the ephemeral that is a vital part of the scholarly record and the context that surrounds this code. And so with that, I will pass it off to Talya, which will give us more information on these archiving approaches.
Is it working? Okay, great. Please bear with my combination of jet lag and multiple devices to toggle between. That being said, hi, as Martin mentioned, my name is Talya, and I'm software curation specialist at New York University. I'll be speaking about New York University's work on the Collaborative Software Archiving for Institutions, or COSAI grant, founded by the Alfred P. Sloan Foundation. The grant is a collaboration between NYU, Old Dominion University, and LANL, and includes Emily and our wonderful host, Martin. So Emily discussed the growing numbers of research work that takes the form of web-based software, that more software is being produced and cited by researchers. She also discussed that currently, in order for a scholar to ensure the long-term preservation of their own software, they must intentionally deposit it in a preservation repository that's equipped to handle software. A 2021 study found that only 26.5% of researchers who identified themselves as software creators chose to take that step. Other research software is preserved incidentally in web archives. Again, as Emily pointed out, that does not necessarily lead to consistent archiving of the entirety of the repository or the preservation of the kind of surrounding web context. However, the tide of this may change as a major shift has begun to take place in the academic data and software worlds, which is that many funders now require that grantees make their work public in open repositories, not just the papers, but also the code and the data that leads to the results published in the papers. These mandates have twin goals of making code and data available to other researchers and also allowing external researchers to assess the validity of the published work's findings. Ensuring that software is preserved to meet these mandates' goals, i.e. that it's fair or findable, accessible, interoperable, and reusable for the long term, is not a straightforward proposition. So, in the case of the software that we're talking about, we have the complexities of web preservation, but also the intricacies of preserving software itself. Software is more of a process than an object. It's a set of interconnected instructions that tell a computer, sometimes a very specific computer, what to do. A user also needs instructions. With research software, it's often not intuitive. Software is built on top of other software, known as its dependencies, without which it won't work. And the creation of software is also a process involving changes by multiple creators and contributors over time. Documentation of all of this contributes to an understanding of how the software was designed and how it's intended to function. And there's also a definition question with research software where it can be just as simple as a script that runs over a data set to produce a graph or an image, all the way up to tools that are quite complex and basically infrastructural for given academic fields. So what our project hopes to do is, I'm sorry, I missed a slide. Classic. What our project hopes to do is to create a tool and a suite of workflows to help institutions help their researchers to ensure the work that they do online is properly preserved and archived. In keeping with the work of Martin Klein that Emily discussed, we see both the development of software and contributions to software and its associated communities via platforms like GitHub as part of an individual scholar's research work and thus worthy of preservation. So I see our work on this project sitting at a busy intersection of different preservation worlds, using web archiving tools to preserve software. At the same time, to this point, the work around preserving research software has taken place in the data curation world, a field which has evolved a lot of the theory and principles around assessing the usability and reusability of data and software, partially in response to the sharing mandates I described earlier. At the same time, we're trying to collaborate with and bring in techniques and efforts that are happening largely in a more special collections-facing context. We're looking at that world and that work not only for emulation models and tools, but also so we can think about how to avoid the problems that folks with legacy softwares are facing, looking at media and software that was created on old and now obsolete computer systems and having a lot of difficulty in ensuring their ongoing usability. So we're really trying to bridge all of these worlds and apply these techniques to research software. At NYU, the first step of the project was to develop a policy document, of which this is an excerpt, to describe what's in scope. Both the types of software and the aspects of these web portals that should be captured as part of the project. So we determined that for our institution, what's important is tracking changes to the software over time and how different contributors participated, as well as the software itself. So we decided that in addition to the code, we would archive issue threads and pull or merge requests. In our policy, we also defined what types of software we would and would not include. For example, class assignments and syllabi are not necessarily research products and thus not really in scope for the project. We did hit a little bit of a bump when we started thinking about how to discover relevant repositories. Initially, we thought discovery of relevant and in-scope repositories on these platforms could be automated, which would help us to address the dearth of people self-archiving their software. It's a little more complex, though, because there's no institutional affiliation or email domain searchable via GitHub API, and since our scope dictates that we're only looking at the work of active NYU scholars, it became a little bit harder to find. Also, a user that self-identifies as belonging to NYU might not necessarily have only scholarly repositories as part of their work. They might fork other repositories from curiosity, join hackathons, and so on. This is an example of a professor's GitHub profile, which includes a personal project, course materials, and a conference presentation, the latter of which would be in scope. The first two would not necessarily. Also, despite the open licenses that most, although not all, software on these platforms has, I was thinking through potential consent issues. At this point, we're thinking about trying discovery using ORCID IDs, finding users affiliated with NYU who have their GitHub account linked to their ORCID bio, which would indicate that they themselves see it as part of their scholarship. At the moment, though, we're relying on self-submission from people in the community who approach us to archive their work. So this is a diagram of the proposed workflow for creating an institution-based capacity to archive research software from the web. It's kind of complex, but it involves a series of open source tools. Memento Tracer is a web archiving tool created by Los Alamos. Occam is a software archiving tool created by Wilkie, formerly of PET. We're also integrating web archiving fidelity tools created by Old Dominion University. At NYU, all of this has been happening at the same time that we've been rolling out an instance of Invenio-RDM, an open source repository software that we have just begun. We just implemented about a month ago. So theoretically, it works like this. Using Memento Tracer, you archive the GitHub page that hosts the software. That trace happens within Occam, which clones the code itself and packages the work and the software code with metadata. That package then gets piped into the repository where it can be discovered. And there's an additional potential inclusion of a tool called Emulation as a Service infrastructure, which is a federated tool for emulating software environments. As you might imagine from all of the moving parts here, building and rolling out the system has not gone entirely according to plan, but we do have some significant achievements on the one hand and useful and informative findings on the other. So this is kind of zooming in on the workflow, and I'll talk a little bit about the specific tool, Memento Tracer. So that was developed at LANL, Los Alamos, and I possibly presented at a previous Iipc. But the way that it functions is that it's a browser extension that looks at CSS selectors and or XPath elements in a site's code. A user selects which of these elements they'd like to click on and have archived. The tracer creates a JSON template. A web crawler then traces pages following that template. So this allows for repeatable web crawls of sites with like structures, which is great for something like GitHub, in which almost all GitHub repos have identically formatted pages. So we've been able to develop kind of canonical JSON trace files that follow our selection policy and work for GitHub and GitLab. So far, though, we have not successfully been able to trace Bitbucket and SourceForge because of the way that the tool works. For example, SourceForge pages allow for a lot of customization, so we have not been able to make a canonical trace. Another piece of the work that we're doing is connecting the workflow to Invenio-RDM, which is our institutional repository. We're making it compliant with the Memento protocol to improve discovery and facilitate interoperability with other web archiving protocols. We're also hoping to integrate the Replay Web plugin into Invenio-RDM, which will enable the replay of the work that's associated with web-based software in the IR context, which would be very cool. As I mentioned, we were also hoping to add a direct link out to EZ, the Emulation as a Service infrastructure. One difficulty with that is that as the development of our project happens in tandem with the creation of Invenio-RDM, which is another open source kind of worldwide collaboration, there are things that we're hoping to use that are features of Invenio that have not yet been rolled out. For example, right now, Invenio does not allow for the creation of more than one metadata profile. Software demands extremely complicated metadata. Specifically for software replay, you need very detailed information about a software language, computing infrastructure, dependencies, replay environment, and so on. So until we're able to capture all of that information either within the software object or in the institutional repository, that piece of things is kind of on hold. So that's another kind of to come. And finally, for next steps, we're just hoping to complete this development and document it, to open source the plugin for Memento compliance, to work towards programmatic QA of the repositories that we will be archiving, and to continue advocacy work for preserving research software. And thank you very much. I will hand it over to Sarah.
I'm so pleased to be here. This is my first Iipc. It's incredible to be on this panel with these amazing panelists. And as Martin has explained, I'll be speaking today on a project currently underway with some institutional funding from the Texas A&M University System Office. And we're exploring the need to design a socio-technical intervention to mitigate against reference rot in electronic theses and dissertations. So Martin and I have been working on this project with our brilliant colleagues from Texas A&M, Tina Budsize-Weaver and Kathy Anders. And I just wanted to say at the get-go that this team represents some interesting and overlapping. We have sort of a Venn diagram of overlapping and unique expertise that we're bringing to this project with digital scholarship, workshop design, surveying and assessment, of course, reference ROT and web archiving, and also extensive work with thesis management, graduate professionalization, and humanities and arts research methods. So the goal of this effort is to tackle a problem that will be very well known among a web archiving professional community, which is reference ROT. And we're doing it with a particular community of graduate student researchers. So like everyone else, graduate students are increasingly reliant on web-based content, and reference ROT, which bundles together link rot and content drift, threatens the validity and the reproducibility of graduate student work, including theses and dissertations that rely on web-based content. Electronic theses are also typically wholly managed within the confines of the university, and more on that later. But working within that scope avoids the question of whose responsibility it is and coordination among complex entities, such as professional societies. Further, as far as we know, and please come talk to me if you know otherwise, because I would really love to hear about it, there are no programs that we have found that systematically train graduate students about reference ROT or web archiving. And there are no tools that we have found that are built into thesis submission systems that mitigate against reference ROT. And finally, I think as we came to this project, we really encountered a meta-research problem. We didn't know what students knew or didn't know about reference ROT. So we've chosen to focus on ETDs. I'm going to use a lot of terms interchangeably here, but essentially these are electronic theses and dissertations. I'll sometimes call them ETDs or theses or dissertations, and they're all the same thing. And we chose to focus on electronic theses for two main reasons. So first, my university, Texas A&M, has a large population of graduate students, and with that, a real mandate to serve their professional growth and to further their training. Texas A&M enrolls more than 70,000 students. We have more than 70,000 students currently enrolled. Typically, around 15,000 of those students are in graduate school. They're earning master's degrees, professional degrees, and doctorates. Texas A&M awards around 5,000 graduate degrees annually. That includes around 750 to 870 doctoral degrees, 3,400 to 3,700 master's degrees, and approximately 650 professional degrees. And these degrees represent a significant disciplinary range. These are just the numbers for master's degrees, by the way. But we are training engineers and policymakers and dentists and nurses and lawyers and business people and artists and pharmacists, architects, teachers, scientists. So the graduate population is really cutting across a really wide swath of different colleges and that are attached to different professions and practices. So that was the first reason. We have a significant graduate population that we're committed to serving and to training. And the second big reason, which Mia Massacott and Kathleen Botter pinpoint in their 2017 article on reference ROT and ETDs, is that librarians and really university administrators more broadly collectively bear greater responsibility for theses and dissertations. They're produced by our students in our university under the guidance of our faculty, administered by our graduate office, and stewarded by our librarians and archivists. So the author, supervisor, publisher, steward, all of us operate within the confines of our single university. So this problem, unlike many other reference ROT problems, doesn't involve contending with publishers, professional norms, authors, and stewards that are really in separate entities that need to be coordinated. Although we do have that disciplinary spread, which involves some distinctive practices. So as I mentioned, we have a special responsibility to our graduate students. And I wanted to talk briefly about what we're seeing in our electronic theses as we're digging into them. So students are citing a variety of web-based content. This includes what we understand to be fairly reliable and heavily managed formal scholarly content, like electronic journals and books, as well as all kinds of what Martin and his collaborators have called web-at-large content. And in a recent small-scale sample, we really found references to just about everything: organizational and government websites, blogs, news stories, conference presentations, working papers, data, video, social media, wikis, software code. It's all being referenced in these works. We're also seeing some strategies that students are developing themselves and that are adopting. They're doing this seemingly without any formal guidance, so they're operating without the training that we're interested in bringing up for them. And they're working to capture ephemeral web-based content within their theses and to make sure that their readers understand what it is. So these are examples that Kathy Anders, Tina Budsize-Weaver, and I looked at as part of a small study. This study is currently under review for the journal portal, so hopefully you'll be able to see it soon. But we looked at how students in Texas A&M's Performance Studies master's program addressed ephemerality in their theses. Ephemerality is a topic of great interest to performance studies as a field. It's a field that is concerned with temporariness and loss and how to capture and document it, or the ethics of doing so or not doing so. So in this example, we have a student who was writing a master's thesis in 2014, and they're linking to a 2013 YouTube video, and they have both transcribed and translated the interview that was captured in the video. So you'll see on your left, that's the thesis with the main text. And then there's the reference captured in the little red box. And of course, the very familiar video not available on YouTube. So this video has since been removed from YouTube. And on the one hand, it's possible that this thesis may be one of the surviving eyewitness accounts of this YouTube video. The film has been removed, but the thesis author has captured a detailed description in ways that an observer might have described a more obviously ephemeral performance, such as an unrecorded play. But on the other hand, the student has included the link, likely with the expectation that readers could verify their claims by going directly to the source. And the source is now missing, and the claims are unverifiable, or at least a little bit harder to track down. And this is a thesis you'll note on challenging Soviet culture and policy. Okay, well, imagine some slides that I'm showing you now. They're extremely visual. So in a subsequent slide, I would show you that a student in 2016 included screenshots from a YouTube video, again, referencing a YouTube video, but instead, in this case, rather than transcribing and translating the interview in a YouTube video, they've taken a screenshot from the video. So this is a more visual argument, and they have included visual evidence from the YouTube video as support for claims that the student is making about Casino Salsa as a performance of a history of Cubans of African descent. And that thesis raises some similar concerns about verifiability if and when the video that they're referencing is lost. And also, as you might imagine, with encapsulating evidence within the text and through screenshots, there's some potential issues related to rights, copyright, privacy, extracting bits into your own work. Emily made a really beautiful graph of our corpus. So thank you so much to Emily for running that preliminary analysis, which I will describe to you. It shows an uptick in URL references in Texas A&M's corpus of ETDs. And so ETDs are increasingly referencing URLs, just like everyone else, increasingly reliant on the web. And we did find in our small scale study, just to give a little bit of a flavor of that, that some students in their work, in their theses, they rely very heavily. It's back. Thank you. Some students rely very heavily and very explicitly on web-based content, so you'll find theses that have hundreds of references to URLs. And other students either are not using web-based content or a different problem. They may be using web-based content, but not citing it as such or not including the URLs. Now things are moving along at a steady clip. So our team's approach over this year has been to focus on research that will inform the development of new practices, workflows, and technologies. We've completed a large-scale survey of graduate students at Texas A&M to assess their awareness and concerns related to reference rot. Last month, we hosted graduate student workshops led by Martin Klein on reference rot. And as part of those workshops, we also ran extensive pre and post tests. So close surveying of a small subset of graduate students who have now gone through training about reference rot and how to mitigate against link rot and content drift in their work. And all of this work was approved by our myriad interlapping institutional review boards. And over the next few months, we will start to actually tackle analysis of the data that we've collected as the basis for recommending an intervention. So for example, we would really like to better understand some of the timing implications for interventions and the types of interventions that might be helpful. One of our long-term goals is to consider whether and how we might build an intervention into open source thesis management tools. Texas A&M uses Vireo, which is an open source software thesis and dissertation management submission system, which is widely used by other institutions. So that would be one way to scale and to bring this work to other institutional settings. And of course, we're very interested in other work to intervene in link rot and preservation issues for graduate theses. So please get in touch if you would like to collaborate. Many thanks. And 2 slides forward, please. Perfect. Thank you.
All right. So please join me in thanking all our panelists real quick. So as you can imagine, you probably got the impression from the last 40 or so minutes of presentations, we can talk about this forever, but really the idea is to hear from you and have an exchange of ideas, concerns, thoughts of that nature. So not giving it justice, we try to put 6 bullets up there that kind of maybe briefly summarize our core thoughts for each individual contributions. And I think it really becomes obvious that we're continuously relying on things on the web, right, and citing those things on the web. However, we're lacking, let's say, orchestrated archiving efforts for these things on the web that we rely on in our digital scholarship. So we're effectively at risk of losing maybe not the entire scholarly record, but certainly parts of that, and therefore, really threatening the integrity of the scholarly record, right? Emily has, I think, impressively shown that with these graphs of things that we cited, however they're gone, right? And not necessarily archived there. I think Talya is the living proof that these sort of institutional or non-organizational efforts require a change in conceptual thinking, right? Even the creation of new roles, and that's what she's representing, that shift there. So I really do believe NYU has taken a trailblazing role in that context. And I think also Sarah had got me thinking, at least, of other disciplines, right, that we're not necessarily embedded in. So what does a YouTube video as an ETD mean for a performing arts student? I had never thought about this, but what does the ephemerality of these sort of resources mean for that scholarship, really, per se, right? So things that you can't print, things that you don't have a version for, things that you cannot reproduce, at least not faithfully, right? So I think that opens a whole new dimension to these sort of sets of problems that we're trying to tackle here. So again, that doesn't give it justice, but maybe just as a brief recap of what we thought we talked about. So maybe now in the remaining 16 or so minutes, we'd love to open the floor and hear from you. I'm happy to throw this blue box around if you care to catch it or not. So we'd be happy to have a lively discussion. So please take it away. And I do need to throw this, right? I do want to throw this.
Oh, goodness.
You good?
You can do it.
That's it.
Good throw.
Thank you. This is really fascinating to hear. I love the idea of using ETDs as kind of this wedge to get web archiving and reference ROT into the minds of grad students and future researchers and publishers. I'd love to hear a little bit more detail about how you're thinking about the students might use web archiving. So, for example, would you say use Safe Page now? Would you say here's how to use a browser tricks crawler on your site, or connect them up with the library's Archivit subscription? And then who sort of takes custody of the web archives? Do they go in the institutional repository, and or the students, retain copies of themselves for another repository of their choice? Lots of questions. Would love to hear a little bit more detail about what you're envisioning.
What a wonderful question. And maybe you would like to join our visioning team because you have offered such wonderful suggestions. I think part of what we really want to do with the survey and with the pre and post tests that we conducted with the workshops is really understand where students are coming from. We had an assumption going in that no one would know anything about reference ROT. That was sort of a working hypothesis. And just looking at the data so far, there's sort of some people who know quite a lot about web archiving and are very invested in web capture of their sources. So I think that's very much an open question for our project. What will the solution look like, and sort of what level of technical expertise can we anticipate there, and who will be the steward of the collection that's produced? I think it also runs into some existing work on thinking about supplementary data with theses and with other scholarly work, and whether this might be conceptualized as a supplementary data file. Yes, so we introduced Martin in his workshops, and maybe you want to talk about this a bit to introduce some sort of different levels of web archiving tools. And I think we have also thought a bit about those sort of tiers of intervention and what different students might need. I mean, students who are completing a thesis and a dissertation are already getting a lot of, they're being asked to do a lot. There's a lot of administrative hoops that they jump through as part of that process. So I think we're very interested in making this not something that is an additional hoop. And with some students, that might mean in some cases that it would be useful to do some level of we'll do it for you with some students, as opposed to really equipping them to do this work. But I do think at this point that we see a value in their knowing what this is instead of it being something that's just done for them. And of course, because web archiving is somewhat interpretive, as well as time sensitive, I think there are some problems with simply automating it. Martin, do you want to talk about it too?
Sure, happy to try to add to this a little bit. So we try to convey the point that, if you only have 2 minutes to do something, try to use what's there, and that's the publicly/openly available web archiving infrastructure. So we do feature things like the spectacular Safe Page Now feature from the Internet Archive, right? Texas A&M is a subscriber of PermaCC as a service. So anything that you can use as a proactive web archiving service, that probably includes archive.is and Megalodon, other services like that as well, is probably a low barrier. So that could be an easy first step, let's say. We further try to convey that screenshots are probably better than nothing, but also not a reliable thing, right? It can be faked fairly easily, we know that. We had discussions around, well, making a copy is good. Making multiple copies is better. Conveying that you have copies in your work is even better. And how to do that in an HTML document is fairly trivial. In a PDF document, maybe less so, right? Especially when your margin police at your university gets in the way and doesn't let you include several links in your citation, things of that nature. So there are, as Sarah alluded to, several levels I think that we try to convey there. But yeah, I think the key point really is, if you make this another half-hour effort in addition to everything else that a student goes through, even a fairly motivated student trying to deliver an excellent ETD, it's not going to happen, right? So we need to really think of these intervention points as getting close or being tightly integrated into the work environment in general. So, think of a plugin for Google Docs or Overleaf, things of that nature, right?
Thank you.
Hi. So you talk a lot about, of course, harvesting it, getting it, making sure it cannot get lost again. But I was wondering, and this is a question for I think everyone, how do you keep it good? I mean, I come from digital preservation, like we work with work validation as well. What is your sort of quality, keeping the quality good?
So one thing that we're doing as part of our project is we're working with a team of colleagues of Emily who have created a tool called Memento Damage, which is a way to look at a work file and essentially see what is damaged. Are there missing JPEGs? Is the structure off? Like, does it not appear the way that it appears on the live web, kind of. So that's and the tool actually creates kind of a score for a website, and that's something that we will be integrating into our workflow once it's one of the many modules that's part of the workflow that we're developing. So that's something that we're thinking about and we're building in. And then the emulation tool that I mentioned is also kind of a part of that, which is thinking about preserving as long as possible replayability of something. So, what is the information that we need to emulate something, and how will we have kind of a ready setup for someone to just kind of be like, all right, well, I don't have Python 2 on my computer, can I just run it, within the repository or within this emulation plugin and ensure that it's accessible as long as possible? I mean, there's a real as long as possible implied with all of this stuff, right? None of us can predict the future, but that's kind of how we're thinking about maximal accessibility and quality assurance. And the other thing is just documentation, having as much documentation as possible. That's one of the reasons why we're preserving the web environment around software, is to get as much information as we can about what it was supposed to do, what people knew it didn't do, when it breaks, how do you fix it, all that kind of stuff. So that's our approach at NYU.
Thanks a lot for your presentations. Have you considered at any of your universities whether or not data management plans or a similar kind of document could be used to at least flag that any content produced for the web or linking to within research needs to be preserved? And just thinking about the preservation of web content more upstream before it even comes time to for a student to graduate, for example, or for a project to end?
I will say that's a fantastic idea. We haven't thought about that yet, but I will definitely take it back to the team to think about it. Do you have further thoughts on it?
It's something that I'm trying to tease out where I work, which is at Cambridge University. So it sounds really nice that you think that's a good idea. So thank you.
I just would like to add that for our project, that's kind of our point of intervention with a student, right, is that they come to us because they need to have a data management plan approved in the application for a grant. And that's the moment at which we say, okay, well, what are you going to do about this? Are you, did you know that GitHub is not a preservation repository? Do you care? All those kinds of things. So I think it's a key moment of outreach for us. I don't think we're in a position where we can actually require students to add anything to a DMP because, as Sarah said, there's just so much pressure around that particular circumstance. But it is, kind of our advocacy moment as librarians to kind of push them towards thinking about more reproducible practices.
Thank you.
So let me briefly jump in here, if you don't mind. And I'm not sure whether you've noticed it. I did on one of Emily's slides. There was a valley on the graph. So for the PubMed Central corpus, SourceForge was dominating early on, but in the 2010 whatever range.
Yeah.
Then was dying off, and then shortly thereafter, GitHub references took off in terms of quantity, right? So I thought that was curious because I would assume that the frequency of everybody citing code has not decreased and then increased again. Did we just cite something different in between? Right? What happened between SourceForge and GitHub, I guess, is a good question.
Yeah, that's an excellent question, and we're looking into that. So I've partnered with one of my colleagues at ODU within the Web Science and Digital Libraries group. They actually created a machine learning classifier thing. That's not my field of expertise, so that's about as much information I have on that. But what they did is they're working to classify URLs that are included in these publications and flag them whether they're open access data or software. And so they're actually, I think, right now, like as we speak, that's being processed. The PMC corpus is being processed, and we're going to look into that. What other things besides those 4 GHPs that we identified, GitLab, GitHub, SourceForge, and Bitbucket, are people referencing? And it's using things like the sentence that it's included in, the citation it's included in, all of that to get information on is this open access data or software. So yeah, that is to come.
So it's a matter of analyzing the URLs, the context around it, to find pointers to code that are not GitHub, not easy to identify as pointers to code.
Yep,
I guess.
Absolutely. I mean, because when you're looking at data, there are tons of tiny, and software as well, very small niche repositories that people are self-archiving their code. But those are really hard to identify, and you're not going to be able to manually identify all of them. So that's where this classifier comes in to help us better understand where are people outside of these main things, outside of GitHub, where else are they putting their code?
All right, I think we're almost at time. I am pretty sure all of us will be around surely today and tomorrow as well. So if you think of any further comments, questions, complaints, thoughts, please catch us, and we'll be happy, as you have noticed, that we'll be able to talk about this forever. So we're excited about these individual efforts, how they come together, what their synergies and overlaps are. So again, thank you for your time. We all really appreciate it, and well, enjoy the rest of your conference. Thank you.